Hello, everyone, and welcome to today's SANS webcast, Simplifying Application Security with Software-Defined Security, sponsored by VMware. My name is Carol Auth of SANS, and I will be moderating today's webcast. Today's featured speakers are Dave Shackleford, SANS Analyst and Instructor, and Matt Vincentis, VMware Security Marketing. If during the webcast you have any questions for our presenters, please enter them into the questions window located on the GoToWebinar interface at any time. Please note that this webcast is being recorded, and a copy of the slides and recording of this webcast will be available for viewing later today and can be found on the SANS registration page. And with that, I'd like to hand the webcast over to Dave.
Awesome. Thanks, Carol. And hey, thanks everybody for being here with us today. Always exciting to be hanging out with the folks from VMware and talking about some progressive topics in the security industry and really talking about application security and how applications are communicating and ideally being not only monitored but protected within virtualized and software-defined infrastructure is top of mind for everybody these days. I mean, we know that we've got a lot of application sprawl out there. We've got a lot of cases where we really just sort of don't have the level of visibility that we know we want into how our applications are operating, and that's got to change, right? We know that this is one of the main drivers for breaches and breach scenarios, as well as how the attackers are taking advantage of us. And so we've got to gain that degree of visibility and start really doing something about how we control our application behaviors. So this is exciting stuff because I really think we are starting to turn a corner in terms of the capability set that we've got. Looking at how we've architected and defined our infrastructures today. In fact, one of the things that I've sort of been on I won't call it a soapbox. It's not quite a soapbox, but it's much more of a sort of thought train, I guess, if you will, in the last, say, 6 to 12 months is just the idea that having a software-defined infrastructure, having a unified backplane that we can query and use as a policy enforcement level gives us incredible advantages over what we've done in traditional data center environments. If you had the ability to control and monitor everything in your data center all in one place, well, wouldn't you? Of course. I mean, everybody would agree that would be a great thing. Well, now we finally have that, and that's the exciting part about using some of these newer technologies that are sort of advancing and evolving. And of course, VMware is right in the front of that, and that's why it's exciting to be able to sort of drill in with these guys and take a look at how they're doing it. So I'm going to start us off. I'm going to kick into some discussion around what's happening out in the industry and sort of how I've seen this both as a security consultant and as an instructor at SANS, working with my students in classes. And then I'm going to hand things off to Matt, who's going to give you guys some pretty deep insight into what they're doing over at VMware and sort of how that's helping VMware's customers put this stuff into perspective and really start taking that control back of our application environment. So really exciting stuff. Let's dive right in. So again, I'm going to sort of kick us off. We're going to talk about really what's going on out there in the landscape. And I think everybody knows this. As I always joke, I start with the Captain Obvious slide that tells you everything you already know. and I think this is something that most of us would agree. We really do need to acknowledge the fact that the landscape has changed significantly. And if you look at things like our network level controls, I mean, we're still actually relying very heavily in many environments out there on traditional network-based isolation and access control strategies. And so look, I'm not saying that the network has gone away. It most definitely hasn't. There's all sorts of new definitions of the quote unquote perimeter and how we're sort of segmenting and isolating things. But the reality is a networks-based strategy alone really just doesn't cut it anymore. And we know that, and we started to figure that out. So if you're relying on VLANs and access controls and firewall types of technology, that's great. Those are still very valuable parts of our overall security stack. But how the applications are intended to communicate and looking at that as really the defining policy definition point, I think makes a ton more sense. And so if you really look forward, I think it's the application control that we need. It's not so much just saying, hey, this port, this service, this type of packet going across the wire. And I come from that background. I'm sort of the old school packet guy at heart. And I've just acknowledged the reality that is not really cutting it. We've got to move forward. So we've got to start looking at things like trust and what's trusted in the environment and the relationships between assets and applications. We've got to look at the behavior of those apps and whether that's quote unquote normal. Most organizations have very little idea of what a normal application, behavior really is. Especially the bigger the organization, it just gets out of control. It's sprawl. It's tough to manage and keep up with. And then having some sort of a dynamic policy engine in place that can not only enforce application behaviors as we'd like them to be, but is capable of modifying that behavior as the applications themselves change. Because look, we don't live in a static world, especially with the world of DevOps and cloud, where things are highly dynamic and we're propagating assets out into virtual infrastructure and into cloud environments at a rapid pace, and things are just dynamically, sort of churning all the time. If you're building a static rule set that is, basically predicated on what was in place 10 minutes ago, it might not really be the case right now. So you've got to have a dynamic policy toolkit that can help with this. So this is, again, why it's exciting, because having that software-defined backplane is really the key to the whole thing. So we see different methodologies in our data centers today. If you look at the data center sort of versus the end user scenarios, I mean, the end user situation is one that I feel like we're starting to get under control. I mean, it's phishing attacks and other things that lead to that ingress coming from endpoints. But at the core, I mean, the core is where the real assets live. And so we have to take a little bit of a different tack, I think, in approaching this. If you look at what attackers are doing when they gain access to critical assets and systems, we've got a lot of great sort of, looking back history to be able to tell us what it is they're usually doing as part of their attack strategies and scenarios. And the number one thing you'll find is that these guys tend to sort of set up shop on systems that they gain access to illicitly. And then they might modify certain binaries. They might change some of the communication patterns coming from those systems. Obviously, it depends on the goals, and it depends on the stages of the attack. And that's something that Matt's going to talk about a little bit more here in a minute. But in various stages of these attack patterns that we have started to, I think, get a grasp of, you'll see things like command and control traffic that doesn't really meet normal traffic patterns. You'll see evidence of data exfiltration through a number of covert channels or sort of hidden channels. You see lateral movement where systems are trying to communicate with one another. All of those are cases where if we know what we're looking for and we have the degree of granular visibility that's needed to see that, we can start doing some very cool things and identifying it hopefully early and preventing these scenarios from getting worse. And so we've got to have a deeper understanding of really, again, not just the traffic patterns and so forth, like I said, but we've got to have that combined approach. We need to know what's going on the systems, who's modifying services or user activity or local sort of file and directory access that might not quite meet the normal patterns of use. And then couple that with the applications themselves and how they're interacting between systems across architectures. And if you look at most traditional controls that we've used and relied on for years, they just don't have that capability. We just haven't seen that consistently as something that we're able to sort of tie into. And that's where our problems, I think, stem from. We've got too much on our plate in some ways to really be able to address all of this. And to me, that's why we have some new opportunities. If we look at this concept of software-defined security, I mean, everything's software now. The age of physical assets, it's not dying, but it's definitely diminished. Very few organizations rush out to buy new hardware, and I think we all know why. And what we've instead done for the past, really well over a decade is we've virtualized and we've condensed and consolidated assets to be able to run in more of a software-defined manner. And now, of course, that's been extended out into hybrid cloud types of architectures and methodologies. And I don't think I need to tell everybody here that the cloud is taking off and is growing exponentially. You all know that. But what we're seeing is this rise of, software-defined everything, really. It's compute, it's storage, it's networking, it's even the management components and toolkits. It's just all of these things together. But this provides the security people out there, myself, you guys, with some opportunities that really I think we've never had in the past. right? I mean, this is why I get excited about this stuff. And I started to get excited about it in the late 2000s because I got very heavily into virtualization, and I realized, oh my gosh, virtualization is that engine that's tied to everything. If you look at the hypervisor and the platform that everything is sort of linked into, all we have to do is build an enforcement engine that's inside that, and now all of a sudden we can do incredible monitoring and tracking and blocking and applications here sort of policy filtering. It's just incredible. So the questions we need to really think about as we're starting to use this engine, starting to use this hypervisor backplane is, number one, what the heck do we have running in our environments? I mean, the whole concept of inventory, not only of systems and applications, but behaviors, is really a fascinating element of security today. So we need to know what that is. What does that look like? What is our application traffic? And we need to sit and watch it and go, well, what is this, right? What does it look like? Is it good? Is it bad? Is it indifferent? Do we need to have some better sense of what's actually happening and say, is this normal? Is it expected? Is this something that we can track and control? And then start building things like alerting and response options around that. And I know, again, personally, as someone who started in the industry as a network security analyst, if you had asked me 20 years ago, what's actually happening in your environment all over the place, and is it normal? Is it okay? If I had been, feeling honest that day, I would have said, I don't know. I might be able to tell you traffic patterns to some degree. I mean, I could get flow data and I could get things like, firewall alerting, but what does a normal application architecture do, and what is it supposed to do across the enterprise? That's a tall order. And so that ability to tie into this unified software-defined backplane gives us way more than we've ever had there. So good stuff. And you throw into the mix today the fact that things are getting much more dynamic. And this has been a rapid shift. In fact, it's just been the past, I'd say 3 years, maybe 4 years, where we've seen people wholeheartedly embrace this DevOps movement. And even if you're not a full-fledged CI/CD pipeline where you're truly pushing things out into production all the time, I mean, let's face it, a lot of organizations just aren't ready for that. But you can embrace the DevOps side, you can embrace the continuous integration and rapid propagation of new images, sort of perspective, even if that's moving into a test build scenario before you propagate to production. We can do that. But what's happening through the use of virtual machines and containers is we're not letting the life cycle, sort of linger as long as we used to. So people are creating systems that might only live for an hour, and then they get torn down and new ones get created. But if you're trying to track static assets that showed up an hour ago, and your expectation is, well, this asset showed up and it'll stay around for days or weeks or months or even years, that is absolutely stopping. And we've got to change how the enforcement plane is able to respond to that. In other words, if I say, hey, these 7 systems are interlinked in an application architecture, cool. But what if those 7 systems die in an hour and entirely new systems take their place? On what merit or basis are we building the policy engine that is able to, sort of build that architecture dynamically from a policy standpoint and then enforce it? And so having that sort of dynamic aspect within the policy engine itself is a huge, huge part of this. And this just requires deep introspection. It requires a policy engine that is sort of inextricably linked to all of the elements in the infrastructure and able to keep up with that as it's changing and as things are ongoing. So that's where, in the past, I mean, the physical data, data plane and control plane just haven't been able to keep up. So moving in a new direction is key for us. And I think security people are really starting to embrace this, which is exciting. It's honestly great to see the security industry and the community rally around this concept of software-defined infrastructure and sort of acknowledge the fact that, there's no going back. Nobody's going back to wholly physical infrastructure or environments. And that means that we're going to have to embrace the tools that are now on the table that give us that enforcement capability and start continuously monitoring. And I do believe, by the way, that we can do continuous monitoring now. In fact, if you had said to me, hey, is continuous monitoring going to be a reality back in 2005? I might have been pretty skeptical about it because it just sounded like a buzzword. today it's not a buzzword. We can do it, and you have the tools available to you to do it. And what we look at is that introspection. So looking at workloads, looking at the traffic that they're sending, looking at whether they're behaving normally versus abnormally, and then building response options that might block communications or take snapshots for forensic analysis, or even shutting down virtual machines if we're feeling bold. Those are all things that we actually can do now. We can do like either automatically or semi-automatically, or however we choose to go down this road. So pretty exciting stuff. We're not quite at the Q&A, so we're going to just skip past that. And I'm going to hand this off to Matt to give you guys some insight into what VMware is doing with their customers and how they're evolving their solutions to be able to accomplish some of this stuff that I talked about. So Matt, off to you.
Great. Thanks, Dave. Can you hear me okay?
Hear you great.
Excellent. Thank you very much. And hey, everyone. My name's Matt Vincentis, and I'm the Director of Product Marketing for Security Products at VMware. And I think Dave did a fantastic job of, giving us an overview generally of some of the challenges that we're facing within the industry as practitioners, and really some of the opportunities, broadly speaking, that we have with respect to the way that we can think about security differently in a software-defined way. Now, I'm going to talk more specifically about what VMware is doing to help you guys address these challenges and take advantage of those opportunities. To set some context up front, so I'm going to be talking about a new product, or a relatively new product at VMware called AppDefense. We launched AppDefense back at VMworld at the end of 2017. And it's a security product that's designed to protect applications running in virtualized environments, running within software-defined data centers. And so to be really clear, what that means is AppDefense is designed to secure server-based applications and servers running in our data centers and in our clouds, not on laptops or mobile devices. So this is not in the end user space. These are data center and cloud applications. So that's important to keep in mind as we go through this presentation. So in terms of what I'm going to cover, I'm going to talk about how we're taking a new approach to security, and then I'll really dive into how AppDefense works in some detail. I'm going to give you a customer story of the Interfaith Medical Center and how they're using AppDefense to change the way that they're doing security. Then we'll wrap it up at the end, and we'll have time for Q&A. So please, just as a reminder, if you've got any questions throughout the presentation, drop them in the questions box, and we'll have time to answer those as we go through at the end. Really, to kick off here, I wanted to talk about the MITRE ATT&CK framework a little bit before we dig in. Now, I'm sure many of you as security practitioners are familiar with the MITRE ATT&CK framework. It started to gain a lot of traction within the industry. I was at the RSA Security Conference in San Francisco last month, and a lot of discussion about the MITRE ATT&CK framework, and MITRE were there themselves. For those that are unfamiliar, MITRE is a not-for-profit corporation here in the United States, and they run the National Cybersecurity Research and Development Center. And their attack framework essentially maps out all of the different tactics and techniques that an attacker may be able to use or compromise to gain access into an enterprise network. And so it's a really good way, a good framework, and a good way to evaluate what attack techniques the different security products are designed to protect against. And so I'm going to use the attack framework throughout my presentation here to help you contextualize the problem that we're specifically solving with AppDefense and how AppDefense works. And, if I think about as an industry where we're spending most of our time and most of our investments, it's really at the deliver phase of the attack. We're spending most of our time and most of our money on cybersecurity trying to stop threats coming into our organizations. So if you think about firewalling, you think about antivirus, anti-malware, IPS, all of these sorts of security products and controls that we're putting in place, they're all really designed to stop threats from being able to come in to our organizations. This is a really, really tough challenge for us. This is a hard battle to fight because there are effectively an infinite number of possible threats. And new threats emerging every day, new vulnerabilities and variants of threats being discovered every day. And so trying to identify these and trying to stop these with signatures and stop them from being delivered into our organization is next to impossible. We might win a lot of the time, we might win most of the time, but you only need one threat or one attack to slip past these defenses to cause damage. And so trying to beat attackers at their own game is really a losing proposition. Now, there is a more effective way to stop threats. When we think about the latter stages of the attack chain, the attack techniques are more well defined. So attackers in a later stage of the attack chain have to do certain things. They have to, for example, execute a tool or connect to a command and control server, those sorts of things. So in other words, we have a finite set of things that an attacker has to do in the later stages of an attack versus an infinite number of things in the delivery phase. And so if we can stop these techniques from being able to execute, we effectively break the attack chain and stop the threat. The problem is, as security people, as practitioners, we don't necessarily have the visibility or understanding into how our applications are supposed to behave. You know, as Dave mentioned earlier, with the sprawl of applications, the rapid pace that they're being updated and deployed, how do we actually know what is good application behavior or what might potentially be malicious? So think about this as an example. You know, there's a machine somewhere and a new binary has been executed on that machine, or a new service has been started up. How would we possibly know if that is a potentially malicious executable or a legitimate service that a developer has just deployed as part of an application? Most of the time, as security people being one step removed from the applications themselves, we simply don't know whether that is good or bad. And it's a significant operational burden for our SecOps people to try and figure that sort of stuff out and figure out if some application behavior is legitimate and known good or potentially malicious and bad. And as an industry, we tried to solve this problem with whitelisting. And ultimately, whitelisting is the right approach to help solve this problem. Only let good things run and nothing else. And if only good things are running and nothing else, then you effectively, again, stop this attack chain. But the problem here is that the manual rules that we have had to write for these whitelisting solutions to whitelist application behavior are just far too brittle. Back to Dave's point earlier about DevOps and whether your organization is embracing DevOps or not, simply the fact that in a software environment, in a cloud environment, we can deploy and update things much more rapidly than we have ever been able to in the past. The pace of application change just means that manual whitelisting rules and whitelisting policy is far too brittle. Either the whitelisting policy never catches up to the application's current state, or as the application changes, it's triggering a lot of alerts or a lot of false positives. And that's, again, a huge burden on our SecOps people or whoever's responsible for incident response. And so AppDefense is really designed to help solve this problem. And there's really three key pillars to the way AppDefense works and the benefits that it gives you in your environments. Firstly, it's about ensuring good. So we're effectively flipping the model in terms of how we identify and stop threats by focusing and validating how applications behave rather than trying to identify and trying to chase an infinite number of threats. So unlike your traditional solutions for securing applications and VMs and cloud workloads that are signature-based, where they're trying to identify those threats, AppDefense flips that to validate how applications should behave and then monitor for deviations from that known good state. And I'll talk a little bit more about how that works in the coming slide. The next point is around visibility and the visibility that AppDefense gives you. And this really comes back to our unique position being the hypervisor. And by the way, AppDefense runs inside the vSphere hypervisor. It's a separate product, but it is a module that runs in the vSphere hypervisor. And from this location, we have an incredible amount of context into how applications are behaving and working. Firstly, we see the applications at the start of their life being provisioned on the system, so we can see exactly what is being provisioned. But also, again, being the hypervisor, we can see every network communication because that goes through the hypervisor. We see every executable that's executed on that machine, disk access. We see it all because of that unique abstraction layer that we sit in between the underlying physical infrastructure and the network and the applications that are running on top. So we gain an incredible amount of visibility that we can use to make smart decisions about policy and about security. And then the third piece, again, to bring it back to Dave's point around DevOps and rapid application change and development and deployment, AppDefense adapts as applications adapt. And so it's not a manual whitelisting policy type of approach where someone is manually creating rules. It hooks into provisioning systems, whether that's systems like Puppet and Chef and Ansible, or there is a learning mode and a discovery mode where it can discover what your applications are doing, and then it's able to adapt as they change. So an example of this might be, you're running Windows updates on a bunch of VMs, or your Windows team are running a series of Windows updates. That would normally trigger a whole bunch of alerts for many different whitelisting systems. Operating system files and executables and binaries are changing, but that's intentional. We meant to do that, so it shouldn't be firing off a bunch of alerts. That's known good behavior, and AppDefense can deal with that. Not only that, it helps to augment NSX as well. So, quick overview: NSX is our network security product that helps customers implement microsegmentation in their environment, and AppDefense can also integrate with NSX to help to dynamically change and adapt microsegmentation policy based on what AppDefense knows about the application. It's pretty interesting stuff. It's just an overview, but now I'm going to dive a little deeper into exactly how AppDefense works to really give you a good sense of what we're doing here. So let's get into the details. So from a high level, as I mentioned earlier, AppDefense is a security product. It's designed to protect applications in virtualized and cloud environments. And as I mentioned, it's actually built right into vSphere. So it is a separate product that you install and manage, but it runs as a module directly in the vSphere kernel itself. So what that means from an operational perspective is no additional agents to install and manage. It's also, from a security perspective, isolated from the attack surface. So by running in the hypervisor, we are outside the attack surface. So if an attacker gets into a workload or into a VM, they are not able to disable AppDefense controls. It's very different in the way we normally think about security on an endpoint, where the endpoint security product itself, the agent, is vulnerable. It's part of the attack surface. It can potentially be disabled or modified. But that's, again, one of the benefits of this abstraction layer that we have with the hypervisor, and building security into that means we are isolated from the attack surface. This is essentially means that AppDefense becomes an intrinsic part, and security becomes an intrinsic part of the software-defined data center infrastructure that most of you are already running in your environment. In terms of how AppDefense works exactly, it really takes a two-phased approach. The first phase is the discover phase, and I'll double click in the coming slides into how this works, but just from a high level, phase one is about understanding what's running in your environment and verifying that that behavior is good. So we discover all of the VMs, all of the applications, the network communication patterns, all of those sorts of things. We discover that and we validate whether it's good or not. Then the second phase is the protect phase, where we can take an automated response to any of the deviations that we notice from that known good behavior that we've discovered. So some customers stop at the discover phase. For some customers, just the visibility alone in understanding what's running, what VMs are communicating to what other VMs, on what ports, and what executables are running, and whether they're good or not, is value enough from AppDefense. And they can often justify the purchase and the installation of AppDefense purely from that visibility aspect. And then others, of course, want the automated response to help to streamline their security incident response processes. Let's double click into a little bit more detail into these things, and we'll start with the discover phase. So as soon as you turn AppDefense on, it starts to discover what's going on in your environment. And so this is all about analyzing and verifying application behavior. So we start by defining the roles of each of your applications. So we're essentially putting the applications into buckets based on which machines are communicating to each other. And we give you some deep visibility into exactly what's going on inside each of those applications. So understanding the composition of each application, what servers make up a particular application, what processes or services are running inside those machines to support that application, how they're behaving, how they're communicating across the network, some of those sorts of things. And then we verify this behavior with the help of what we call the App Verification Cloud. So the App Verification Cloud is a cloud service run by VMware that combines machine learning and machine learning algorithms with human intelligence in our security operations centers to help you verify what good application behavior is. So for example, again, you notice a specific executable running on a machine. Is that good, or could it be malicious? Does the hash of that executable match something that we know is good? For example, if it's a Microsoft SQL server running SQL.exe, we validate the hash of that executable, and we'll give you a green tick if it's good, or a red cross if it's potentially bad. And so what that means is it takes the bulk of the heavy lifting off you as security practitioners to decide what's good and what's bad. We do a lot of that pre-validation for you. Of course, you might have custom applications in your environment. We understand that not everything is off the shelf and known good applications from vendors. So we'll flag that stuff during the discover phase as unknown. That is a snowflake in your environment and something that you'll need to validate whether it's good or not. But we take, like I said, the bulk of the heavy lifting off you, and hopefully that reduces the amount of application behavior that you have to manually verify. And like I mentioned earlier, customers have told us that this visibility and this verification of application behavior alone is enough for them to be able to justify implementing AppDefense. But of course, we do take it a step further when we move AppDefense into the protect phase. So in the protect phase, this is all about automatically responding to deviations from that good application behavior that we've just discovered to help automatically stop threats. So when a potential threat is detected, we of course get an alert. Step one, get an alert. We can pump that into your SIM or whatever your operations center uses for incident response. But we can also automatically, if you wish, take some sort of automated action at that point. So for example, we could block a process from executing on a machine, or we could, with the integration with vSphere, the fact that we're in the hypervisor, we could take a snapshot of a VM that's potentially bad for later forensic analysis. And there's a whole runbook of different automated actions that we can take when we notice a deviation from that known good state. The App Verification Cloud comes in again at this point by helping us to classify the alerts that we do find and help to reduce alert fatigue on your SecOps folks. So again, by using some machine learning algorithms in the back end, we can help to categorize and help to prioritize alerts based on, a number of different metrics. And so, as an example of how this might work in reality is perhaps the hash of a binary does change on a machine. With some whitelisting solutions, that would be enough to trigger an alert. But again, what if that binary change was completely intentional? It might have been a Windows update process that's changed that binary. Well, we already know that is known good and that the new binary is good and verified. So the app verification cloud can adjust the severity of that alert to make it low so that it's not popping up on a SecOps screen for someone to have to go and respond to. So that's sort of how AppDefense works and what it is from a high level. Now, I really want to sort of drill into, or put this back into perspective, looping back to the MITRE ATT&CK framework, and actually talk about the types of attack techniques that AppDefense is designed to stop throughout the attack chain. Now, this is just an example of some of the attack techniques across the MITRE ATT&CK framework. It's not all of them, but I'm going to use this as an example for exactly how AppDefense works and the sort of attacks that it would stop. Essentially, AppDefense is designed to prevent these attacks from being able to successfully execute. So again, rather than focusing on trying to identify specific threats or variants of threats, we're trying to stop the attack techniques themselves from being able to execute by validating known good versus chasing bad. So some examples here of well-known threats. I'm sure all of you are familiar with some of these threats up here, whether it was WannaCry or the Equifax breach, or what happened at the Pyeongchang Olympics, NotPetya. These are all very common attacks that have been front page news and gained front page media attention over the past few years. Some of them caused millions of dollars in losses. Some of them downtime to organizations, like the WannaCry attack. Well, AppDefense would have stopped these attacks from being able to execute. AppDefense is designed, because AppDefense is designed to stop those techniques themselves from executing, it effectively would have stopped those attacks. So before we finish up here, I want to just take you through a case study of a customer of ours who is using AppDefense to help strengthen their security posture. The Interfaith Medical Center are a safety net hospital in Brooklyn. They treat over 250,000 patients every year. Now, the fact that they're a safety net hospital, for folks outside the United States or who may be unaware, they essentially provide care to low-income and uninsured patients. And so they're publicly funded, which means they need to be very careful with how they use their funding. They are still a hospital, though, so they still have patient data and patient information they need to keep secure, and so they do have a target on their back. And they chose to go with AppDefense to help secure their virtualized environment and help them implement a zero trust strategy. Their VP of Information Security, Chris Friends, his name is, he's actually the author of the OWASP anti-ransomware guide. So, he knows this space very well, and he chose AppDefense to help them implement their zero trust strategy. And interestingly, with their environment during the implementation phase, they actually did a number of mock security incidents. Their red team went through a bunch of mock security incidents, which helped them to create new processes and new best practices for how they respond to incidents. This was post WannaCry. They wanted to make sure that they could respond more quickly to an attack like WannaCry, which obviously impacted a number of other hospitals, fortunately not them. But that was a sort of key driver for them to help them streamline their incident response process and respond to incidents more quickly. And so now AppDefense is part of and a critical component of their defense in-depth strategy. They also use NSX and microsegmentation as well and have the two linked together. All right, so let's start to bring this home. And just to recap really in terms of 3 things that I would take away from this presentation. Number one is, I believe it's a far more effective strategy to try and stop threats by focusing on ensuring and validating good application behavior rather than trying to detect a potentially infinite number of threats. And that's exactly what AppDefense is designed to help you do in a software-defined data center infrastructure. Secondly, AppDefense makes it really simple by giving you deep visibility into how your application should be running. That unique position we have as that abstraction layer between applications and infrastructure is the ideal place to gain this visibility and to insert security controls. And finally, it's critical that your security solution, and in this case, AppDefense, can adapt security policy and security control intelligently as your applications change over time. And with that, just a few next steps if you want to learn more from here. Firstly, please visit the AppDefense website, vmware.com/appdefense. We have a bunch of content and videos and other bits and pieces up there if you want to help educate yourself more. Secondly, if you're more hands-on and you want to get your hands dirty straight away, we have a hands-on lab available. It's free. It has the AppDefense product. You essentially, we stand up in our cloud, a real environment with AppDefense running, so you can start to click around and really get a feel for how it works. Or if you want to completely short circuit the whole process and just get in touch with us straight away, there's an email address here on the screen. Please feel free to reach out to us at any point. And with that, I want to thank you for your time and happy to jump into any Q&A if we've had some questions come in. Carol, are you still on the line?
Yes, I am. Thanks for that great presentation. And we do have some questions ready for the Q&A. However, if anyone has a question for our presenters, please enter it into the questions window now. First one says, can you demo this in a live environment, catching a pen tester with a wide scope?
Sorry, Carol, can you repeat the question? I didn't quite hear you there.
Sure. Can you demo this in a live environment, catching a pen tester with a wide scope?
So can we test this in a live environment? Was that the question?
Yes.
Yes, absolutely. Of course, we can test this in a live environment. I'm not sure the pen tester bit. Dave, did you pick that up? Any thoughts from your side there?
Yeah, I think what the person asking the question is probably asking is this something that you could do like a demonstration of? So if you had a real pen tester doing an actual pen test, is this something that could be enabled and sort of facilitate a real-time sort of catch or real-time prevention detection scenario around?
Yeah, absolutely. I mean, that's the process that our customers would typically, take. They would do a proof of concept, whether they, engage an external pen tester or do some pen testing themselves internally. That's absolutely something that we could do. It's very simple to operationalize. And, obviously there's a dependency on vSphere in terms of this runs in a vSphere environment. But assuming you have a vSphere environment, whether you want to deploy this in a test lab to do a proof of concept, or if you want to deploy it in production, if you have the ability to do that, absolutely, that's something that we see customers commonly doing.
All right, thank you both. This next one, Matt, I put into your questions window, so if you expand it, you should be able to see it. It says, how does this defeat live off the land attacks?
That is a question that's probably outside my area of expertise, to be completely honest. So I might have to defer that one. I think that's from Russell. Russell, let me connect you with the right people to get you some information on that.
All right, thank you. The next one is, can AppDefense mechanism check against our VMs, even if they're all encrypted?
Yeah, the short answer is yes. So, while the data on disk may be encrypted, we will still be able to, from the hypervisor position, see network traffic. Obviously, all network traffic goes through the hypervisor, so we will see those network flows. We will also be able to see the executables that are being executed within those machines. So yeah, short answer is yes. It's okay if your VMs are encrypted. We can still, we still have visibility in terms of what's running, what's communicating, and we can deal with that. That's no problem.
All right. Let's see here. Can AppDefense
And actually, maybe
replace...
sorry, Carol, just to expand on that a little bit. You know, if the question was more about network traffic that's encrypted, it depends, I guess, where the encryption is taking place. You know, maybe if you could reach out to me, we could explore that further offline.
Right, thanks. They say, so it can check on VM-based rootkit?
Yes, so that's part of what AppDefense is designed to, you know, protect against and validate. Absolutely.
All right, thank you. Can AppDefense replace antivirus solutions?
The short answer is yes, absolutely, and we have customers doing that. You know, in our view, at least, this is a far more effective control for server workloads. You know, if you think about the difference between an end user device like a laptop or a desktop, where, you know, the user may be doing who knows what random things, installing who knows what on their machine, some of which may be questionable. With a server, with a VM and applications that are running in our data centers and clouds, you know, they typically have one role. You know, it's a SQL server, or it's an Apache server, or whatever it is. It has a very well-known role. And so we believe this approach is much more effective at securing those sorts of machines with a very well-defined role. You know, it's the whitelisting approach versus the trying to detect every possible threat approach. So we absolutely have customers, you know, for their VM environments, getting rid of AV, which typically, you know, is a pain to manage, installing and managing all of those agents, but also consumes a lot of resources running within the guests. AppDefense is very lightweight in the way it works. Not only is it running in the hypervisor kernel itself as a module in the kernel, it also, because of the approach, not having to use signatures to detect threats, it's very, very lightweight, and so the performance impact in the environment is quite low. Now, the only exception might be for some compliance requirements. For example, PCI compliance mandates that in a cardholder data environment, you must be using antivirus specifically. So for some customers, what we see is more really to enable their auditors to tick a box using AV in a small part of their environment just to pass their audits, not because it's an effective security control, but just to keep their auditors off their back. So that does sometimes happen, but absolutely, broadly speaking, AppDefense could be a replacement for antivirus. We also see customers using it as an alternative to host-based IPS for the same sorts of reasons, and also using it to replace some network-level sandboxing type appliances as well. So, you know, there's a whole range of different security products or tools that you might be using that you can potentially consolidate by using AppDefense, and we see customers doing that frequently.
All right, thank you. Is there a trial I can download?
A trial, that is a good question. So I don't know if we offer a free trial at this stage. I think the best way to get started, and if I click back a slide here, if you want to get your hands on and play with it, start with the hands-on lab. So that is it's a full environment in our cloud. We spin up a series of VMs where you can actually play with the product hands-on. You know, it's not an HTML simulation. It is the real product running in a sandbox type environment. I don't think at this stage we offer a trial, but if you like the hands-on lab and you're interested, please email us with the alias that you see on the screen here, and we can organize a trial for you. We can get you what you need to run it in your environment.
All right, thanks, Matt. Do I need to install an agent on all my servers to run this?
No. So I think I mentioned this throughout the presentation, but maybe it was missed. So AppDefense runs as a module in the vSphere hypervisor, and you do not need to install additional agents inside the guest VMs. So very easy to deploy and manage from that perspective. Good question.
All right, thank you. Can I use AppDefense on my VDI clients?
VDI, so virtual desktops. That's an interesting use case. So I kind of touched on this earlier in the Q&A. So the AppDefense really is better suited to environments where we know what should be running. And I'm not going to say static, but, environments where, each individual machine has a very specific purpose. So it would probably depend on the type of VDI. So for example, if your VDI clients had a very specific role, so let's say they were bank teller machines where you've got thousands of these VDI clients, but they really only do one thing, which is run that core banking app. Or if they were clinician machines in a hospital, for example, where they run one very specific healthcare app, AppDefense would be perfect for those sorts of environments. If they were VDI clients that were sandboxes for developers, or if the users had admin access to install whatever they wanted on those machines, AppDefense may not be the best solution in that type of an environment, just because obviously people could be installing whatever they want, and that may generate a lot of alerts. But if the role of the VDI client is well known, AppDefense would be a very good solution.
All right, that's all we have. Does anybody have any closing thoughts they'd like to share?
Hey, this is Dave. I'll certainly chime in and just say, I think, notwithstanding all the things that both myself and Matt have been discussing here in the last, 45 minutes or so, I think what we have to start looking at is a different definition of the security, sort of control stack, and how we define everything from isolation and segmentation and access controls to, even things like intrusion detection and prevention. And start realizing that having that sort of unification of where all of the traffic and information is crossing, you've got one plane of information that we can take advantage of. And really that plane is the hypervisor. Whether you're in the cloud or you're, in sort of a central data center or both, that's where everything is handled now. And so having controls and tools that can tap into that and make use of it as a means of enforcing and implementing policy, that's the future, really, for how we're going to probably be doing not just application behavior monitoring and sort of control, but pretty much everything else as well. So it's exciting to see this stuff starting to emerge and happen. And I think this is one of the places security teams need to focus on more, not only today, but in the future, because this is, like I said, this is where it's going to be happening. So good stuff.
All right. Well, thank you so much,
Thanks,
Matt.
Dave.
Oh, go ahead, Matt.
I was just going to say thanks for those comments, Dave, and I appreciate everyone's time today. Thanks very much for joining us on the webcast.
All right, and thank you so much, Matt and Dave, for your great presentation, and to VMware for sponsoring this webcast, which helps bring this content to the SANS community. To our audience, we greatly appreciate you listening in. For a schedule of all upcoming and archived SANS webcasts, including this one, please visit sans.org/webcasts. Until next time, take care, and we hope to have you back again for the next SANS webcast.